Welcome everybody to another learning instructional video. Today we're going to consider the integral of cos squared theta d theta. And while there are different ways to show this, I'm going to use a trig identity that I've asked us to memorize up to this point. And the one I'm referring to is the following one. Let me write it out and you'll probably remember that I asked us to remember cos of, let's say, a plus or minus even b. This is one of those things that we should memorize, right? And this is cos of a, cos of b. Now the signs get flipped, so it's minus plus sine of a, sine of b. And specifically, if I let a and b be theta, I'm going to get the following. Let's just do the plus. I'm going to get cos of theta minus sine of theta sine of theta. That is to say that cos of 2 theta is equal to cos squared of theta minus sine squared of theta. And now we will replace this minus sine squared theta, or rather the sine squared theta, we'll just recognize that this is nothing other than 1 minus cos squared theta, since the sum of sine squared plus cos squared has to equal 1. That is also a trig identity. So we get that cos of the double angle is equal to cos squared theta, that's that guy, minus the 1 when I distribute that minus here. Okay, minus a minus, that's going to be a plus cos squared theta. And so you see that cos of 2 theta is equal to 2 cos squared theta minus 1. And in fact, I can now solve for cos squared theta. So cos squared theta is going to equal a half. Well, let's go one by one. Okay, so I'll take this one to the other side. So I get 1 plus cos of the double angle. And there's the 2 sitting out in front here. Now let's divide everything through by 2. So we get cos squared theta is equal to a half plus a half cos of the double angle. And now I have a nifty little expression that allows me to sub in for the cos squared of our original integral. So rather than writing or evaluating cos squared theta d theta like we're intending to do, I'm going to sub in the equivalent identity of that form into here. So I get the integral of 1/2 plus 1/2 cos of the double angle theta d theta. Okay, and when I distribute everything, I get the integral. Let's take out the constant half d theta plus a half integral cos of the double angle 2 theta d theta. And let's now do a u substitution. So let u equal the double angle. That means that du equals 2 d theta, or d theta is equal to a half of du. Right? So let's do this now. So this is equal to, this right here becomes a half of theta, of course. Alright, and then plus a half of the integral of cos of u, and instead of d theta I'm going to write a half of du. So this is equal to a half of theta plus a half times a half is a quarter outside, the integral of cos of u du. Alright, we're almost there. And then we're going to find that this is equal to a half of theta plus a quarter of the integral of cos u du is sine u, plus we pick up some constant of integration. And we said that u is 2 theta. So let me sub that back in. So finally, therefore, the integral of cos squared theta d theta is equal to 1/2 theta plus 1/4 sine of the double angle plus some constant of integration. And there you have it. That was simple enough. Hope to see you in a future video. The next one we'll do is very much like this. It is the integral of sine squared theta d theta.